Okay, let's take a look at this multi-dimensional function. F of t is defined as cosine t sine t. So t is the input and the point cosine t sine t is the output. I'm not going to write out numbers 1 and 2, but let's just talk about it. Why is the domain R? Well, I can choose any real number t, and both cosine of t and sine of t are defined. So t can be any real number, and the right-hand side is defined. So the domain is R. Now, the right-hand side is an ordered pair. So there's a x-coordinate and a y-coordinate. It's an ordered pair. Now, the first thing is a real number. The second thing is also a real number. And so we can define, so the codomain can be perfectly defined as cosine t sine t. Now, you might observe that cosine and sine are both bounded between -1 and 1, so it would have been okay to define the codomain to be something a little bit smaller, like -1, 1 cross -1, 1. And that would specify that the x-coordinate has to be between -1 and 1, and the y-coordinate has to be between -1 and 1. So had we chosen this instead of this, that would have been perfectly okay. But certainly the point here, cosine t sine t, this ordered pair, has to be an element of R cross R, or R2. All right, now the more interesting ones. Is the function 1-to-1? Why or why not? This is not 1-to-1. For example, if you take f of 0, that's cosine 0 sine 0, which is 1, 0. So that's the ordered pair 1, 0. If I take f of 2 pi, I get cosine 2 pi sine 2 pi, which once again is 1, 0. So different inputs lead to the same outputs, so the answer is no, it is not 1-to-1. Here's an example to show why it's not 1-to-1. Is the function onto? And for onto, we'll use the original definition of r squared. R2, I mean. It is not. It is not onto because, note, if you take cosine of t squared plus sine of t squared, by the Pythagorean identity from pre-calculus, that must be equal to 1. So all I need to do is find some point where the first number squared plus the second number squared is not equal to 1. So for example, 1/2 0 does not satisfy this. If you take a half squared plus 0 squared, that's not equal to 1. So there can't be a real number t, so that f of t is equal to 1/2 0. And so the function is not onto. So the answer for 4 is no, it's not onto. 5, does the function have an inverse? No. The function can only have an inverse if it is a bijection, and for this one is neither 1-to-1 nor onto, so this one can't have an inverse, so this one does not have an inverse.